My name is Dr. V. Shobramanian, working as assistant professor in Department of Electrical Engineering, Nevada University. Hi friends, yesterday I think we have been discussed how to design the 5 volts DC mobile charger which can convert AC into DC. Might be in sounds little bit disturbance has been happened. Today I will try to rectify that all the technical glitches and I will try to explain lot of things today. Just I am not going any deeply concept, just I am going to giving the shortcuts. That shortcuts is very useful to for doing your GATE exams as well as for MATLAB simulation program, for publishing the papers, for doing the fundamental research. It is very important for you. Before going to my topic, I would like to give the brief introduction about the power electronics. If you are coming to the definition of the power electronics, if you will see nowadays all electronic gadgets, lot of power semiconductor devices are there. If you are going to theoretical subject, the definition is control and conversion of electrical energy from source to the load by using the advanced power semiconductor devices. I can use the word the power semiconductor devices are the heart of the power electronics. So friends, if you are coming to this situation, if you are coming to this manner, lot of devices and power semiconductor devices we have. Means in the devices we have been segregation like 3 ways. One is the uncontrolled switch, semi-controlled switch and the controlled switch. Yesterday I have been told, if you are coming to the uncontrolled switch, diode is the example. If you are coming to the semi-controlled switch, thyristor is the example. If you are coming to the control switch, the device which have the control terminal, these all coming under the control switches examples. So if you are coming to the definition of uncontrolled switch, means on state and off state will be depends upon the circuit condition. Semi-control means definitely control terminal will be need like a gate terminal. If your semi-control means on state will be depends upon the gate terminal, off state depends upon the circuit condition. If you are coming to the third situation, third switch is control switch. On state and off state will be depends upon the control terminal, either gate terminal. If you are coming to the BJT, that is the terminal of the base terminal. Okay. Now today R load and RL load, what is the main difference I would like to tell to you. Listen carefully. If you are seeing the yesterday waveforms, in yesterday waveforms, if you will see, I will by using the MATLAB, I will explain to you. If you are using the R load, the diode has been conducting from 0 to pi, the conduction angle of the diode. If you are coming to the RL load, the conduction angle of the diode is 0 to pi plus something. Pi plus something means the conduction angle is going to be increasing. Means friends, if you are going to solving the gate problem, if anybody have been asked find the average value of single phase half wave uncontrolled rectifier by using the R load, the average value is going to be different. In RL load, find the average value, the V0 average value also going to be different. Because why? If the conduction angle from which point to which point my diode is conducting, if the value is changing, means ultimately all the performance parameters are going to be changing. Means V0 value is going to be changing, VRMS value is going to be changing, ripple factor is changing, form factor is changing, efficiency is changing. These are all called performance parameters. So very important aspect is remembering the waveforms are very important, and the conduction angle of with different loads of diode also very important. If you are giving RL load conduction angle to R load, V0 average is going to be wrong. And if you are going to giving R load conduction angle to RL load, V0 average is going to be wrong. Means the average value, the V0 average means the average output value and RMS values, if they are going to be wrong, means the total performance parameters are going to be wrong. Might be in the question, whatever the answers are there, might be you can get the confused and you can might be give the wrong answer. So friends, before going to the MATLAB simulation, 3 shortcuts I would like to tell to you. Number 1, assume in your mind all the switches are ideal. All the switches are ideal means whatever the input equal to output if the device is in on condition. Like ideal transformer don't have any losses also. What 100% losses. Practical transformer, if you are indulging the lot of losses, efficiency might be vary. Like here I am assuming for my circuit diagrams, for my MATLAB simulations, all the switches are ideal. So if the diode is forward bias or forward bias, then whatever the input voltage equal to output voltage. Means if you will observe in the MATLAB, whatever the input voltage waveform, it will become across the output voltage waveform. Then blocking voltage is nothing but the voltage across the diode. Means if the device will be on state, it cannot block any voltage. If the device will be off state, it can block whatever the applied voltage. You try to remember these points, do 2-3 points. Easily we can understand our waveforms without by hearting any deeply concept. So it is useful for your this whatever I am telling, this concept useful only for how you can remember the conduction angle. By using the conduction angle, how you can draw the waveforms by using the MATLAB simulations. So friends, now we are going to the MATLAB software. Very important software. Not only UG/PG students, even research also going on this MATLAB software. Very big projects also going on. Maximum IEEE transaction papers, IEEE, what can I say, journal or conferences, whatever, scopers, springers, science directors, our electrical discipline peoples are maximum using this software that is called a MATLAB. Both simulation part is there as well as the programming part is also there. Today, two waveforms I am going to explaining to you. One is a R load waveform, another one is a R load waveform. How to connect in the MATLAB simulation, and I will show the conduction angle differences. So integration and these all the things you can do for the homework. So now if you will see the projector, now we are going to the MATLAB simulation. If you are going to the desktop, in desktop you can find the MATLAB icon. If you press MATLAB icon, you will get the MATLAB window. In this MATLAB window, you can go for the Simlink icon. The purpose of this Simlink icon is you can find different power electronics equipment. Not only power electronics equipment, you will get the, means it's like a library. All the components are available here. So just I click the button here. Here see, my Simlink library browser window has been enabled. So in this, whatever you want, you can take it for your user. So in the Simlink browser, I am going to opening one new window. In this new window, now you have to design the power electronic circuit. Now I am going to design single phase half wave uncontrolled rectifier by using R load, and single phase half wave uncontrolled rectifier by using the RL load. Easily you can understand. If my concept is wrong means you can check in this MATLAB software and you can hence prove whether your concept is right or wrong by using the MATLAB simulation. So here single phase half wave uncontrolled rectifier circuit purpose is conversion of AC supply into the DC supply. Practical application of this single phase half wave uncontrolled rectifier circuits are like any AC to DC conversion, like in mobile charger or laptop charger. Which application do you want, you can use. So if you are increasing the quantity of the switches and the value of the supply, the application rates are going to be increasing. Regarding these things, we will discuss later. Today, ultimately, I will make you understand how we can use the MATLAB and how we can do the circuit diagrams of single phase. Future, we can discuss IEEE and SAA Scopus published projects MATLAB simulations also we can discuss. So for this basic purpose, I am teaching this one. So left hand side, do you have the Simlink library browser? In Simlink library browser, you can go for the Sim power system. In the Sim power system, subsystems are there. In that subsystems, you can find different of components. Here, I need single phase half wave uncontrolled rectifier input is AC source. So I am going in the block of electrical sources, and you can drag AC voltage source to this window. And one more is here I am using uncontrolled switch. The uncontrolled switch, it is nothing but power electronics device. The power electronics device, you can go for the diode. I can drag the diode here. And one more thing is I have to take load, because today I am going to explaining about the R load and the RL load. So you can go for the elements. In elements, you can find series RLC branch. In series RLC branch I am drawing, but here my load is only R. So according to my desire, I double clicked here and I mentioned here the load is R and I can do OK. So now my circuit is ready. AC voltage source, diode and the resistors. So here I have to measure voltage across my supply and I want to measure voltage across the diode and I want to measure voltage across the load, and I would like to see what is the flow of the current in the circuit. So now I will go for the measurements. In measurements, left hand side measurement, I will go voltage measurement I will check and current measurement I will take. So one more important thing is Simulink. You go for the things, you take scope. I will tell what is the purpose of the scope. You can see all the outputs in the single. So now my input is AC voltage source. I am putting here, and it is my diode and it is my resistor. So now by using Control R, you can reverse the load according to your desire. Now I am keeping here diode here. I want to measure the current in the circuit. Yes, I am putting here current in the circuit and I am correcting here. So red color is coming means simulation is wrong, connection is wrong. So do the properly, easily, and this one I have connected here. Now I would like to close the circuit. Okay. Now 3 voltage measurements I need. So here I had only one, no problem. Just you can copy and paste here, and one more paste here. So one voltage across input, another voltage measurement across the diode. It is called a blocking voltage. Blocking voltage definition you have to remember. If the diode is on, it cannot block any voltage. If diode will be off, it can block whatever the applied voltage, either positive half cycle or negative half cycle. In waveform, I will try to clearly explain to you. Now another voltage measurement across the resistor. Now I am putting here positive here, and I am putting here negative here, and I am putting here positive here, and I am putting here negative here. So now voltage across the resistor here and here. So friends, now I will take the scope. Now total how many outputs I have? 1, 2, 3, 4. So I will try to enlarge the scope according to my desire. Here double click I will do, and I will go to second one. I will put number of axes are, what can I say, 4, and I will put it is okay. Okay. Now one is here is the input, and one more is voltage across the resistor is here, and third one is current in the circuit, and fourth one is voltage across the diode. So now my circuit is complete. Performance parameters are very, very important. Now I would like to give 230 volts AC supply, and my system is working with the frequency 50 Hz, and I will put OK. And next one is I will give the value of the resistance is 5 ohms, then I will put 5. So rest of the parameters I am not changing. Before that, you try to save the system. So you can save anywhere, no problem. Otherwise I will put in desktop. I will put here diode circuit, then I can do save. It is not saving, no problem. Go to simulation, give the configuration parameters. In configuration parameters, I have to go for the solver. For different of simulation programs, different of solver, I will choose ODE 1560 NDF, and I will give the stop time 0.04, then OK. Let me check whether my concept is right or wrong. Here I have to find total 4 waveforms. Number 1, 2, 3, 4. If input is purely sinusoidal, definitely voltage across this one should be the purely sinusoidal. So now I am running the system. 0.04 with the time I am running the system. Then now let me check what is the output. So scope I will go. I will maximize the system. Then I will make it zoom. So friends, see, input is purely sinusoidal. Input is purely sinusoidal. Second one, if you will see from the simulation diagram, V0, if the diode will be on, definitely the diode will be on from this point to this point, because voltage across the diode is a positive, so it is going to be forward bias. So according to our shortcut, all the switches are ideal. So whatever the V input equal to V output. Now from pi to 2 pi, diode is a reverse bias, so 0. Again second cycle. If you are coming to this waveform, it is a current in the circuit. Same, my shortcut is I will follow the Ohm's law. If you will see the equation V equal to IR, by using the resistive load, V equal to I. Otherwise you can understand that from here to 0 to pi the current flow, and pi to 2 pi there is no current flow because switch is in reverse bias. Now the concept of blocking voltage, if my switch will be on, the switch cannot block any voltage from 0 to pi, that is a 0. If the switch will be off from pi to 2 pi, it can block whatever the applied voltage. So my pi to 2 pi, my applied voltage is negative voltage, so it can block negative voltage. So finally my friends, the conduction angle of my diode is now from 0 to pi. So if you are going to solve average output value, you can give the integration limits from 0 to pi Vm sin omega t d omega t. You will get the answer of Vm by pi. Hope so. Mathematical calculation you can do by using the textbooks, Power Electronics, PS, Bimbra. These all the things. A lot of textbooks are there. So it is a way you have to find single phase half wave uncontrolled rectifier R load. If you want to do for RL load, just double click and I will put RL here. So inductance value is there. So I will change. Here I will put, what can I say, 10 e power minus 03. E power minus 03, 10 power minus 3. In MATLAB, e power minus 03 term we have to use. I will put OK. Then I will save it. Oh, save, we done already saving, no problem. Just run. If you will see output, definitely the spike will become at output voltage, and the peak value of current values are also going to be changing. Now my diode is conduction angle is 0 to pi plus some this value. So friends, very interesting power electronics. Different circuits, different waveforms and different shortcuts. In my next video lecture, I will tell what is the reason of this negative spike and what is the reason why here the current reaches not peak at pi by 2. Because if you will observe R load, just moment, if you will observe in R load, the current reaches peak at pi by 2 here, this value, but in RL load current reaches peak in between pi by 2 to pi, and we got the negative spike also. This negative spike, is it effective to our main circuit or not? What is the harmonic? If my conduction angle will be increasing, what will be happen to my circuit? If my conduction angle will be increasing, harmonic quantity will be increasing or not? If the harmonic quantity will be increasing, what happened to your circuit? For minimizing this spike, freewheeling diode, is it work for you or not? These are all the things. My next video lecture, consecutive video lectures I am going to uploading in future. Please stay on my channel. Power electronics, very easy subject. Tomorrow, my next video lecture, I will try to make a sense how much easy the power electronics subject. Like this, consecutively 60 to 70 waveforms we are going to discussing. Single phase waveforms, three phase waveforms, full bridge, half bridge, control, AC to DC converter, DC to DC converter, cyclo converters, choppers. These are all the things we will discuss in future. So for this lecture today it is enough. Thank you very much. We'll meet you soon.